Hello guys, welcome to Physics. In this video I am going to solve JEST Physics 2012 and 13 previous year problems on electrostatics. A PDF version of this slideshow will be available as a Google Drive link in the description below. So let's start with JEST 2012. In this year total number of questions were 3 and the level of difficulty was easy or basic types. Now, in our first question, the form of electric field is given and we are told to find out the values of the value of the constant ABC, and 4 options are given. So what we know in case of electric field, that its curl is 0. So what we did is we find out the curl of the field and we find out that 6b minus c is equals to 0, which implies b is equals to 1/6 of c. Now there is no way to calculate a, so we will have to assume anything and we have to use trial method to solve this problem. So what is the trial method? So we have to compare our result with the options available in the MCQ, and if we compare we will get that the correct option is the C, that is 13, 1 and 6. So you can tell here that the value of B is 1 and the value of C is 6, that is 1/6. Now moving to the second question. Here a point charge plus Q is placed at a distance D from a grounded infinite conducting plane defined at the origin. Now it is said that there are no charges present anywhere else. So we have to find the magnitude of the field at 0, 0, minus d. Now we will use here what? We will use the method of electrical image. So by this diagram, here by this diagram I have shown a plate and which is earthed. Now I have considered this as the z-axis and this is our charge that is given plus q at a coordinate 0, 0, d. So by the basics, so when we study electrical image, we have to find out that the magnitude of the image charge will be minus q and the position will be exactly same but in the negative direction. So we find out that the value of the image charge, that is minus q, and the position of it is 0, 0, minus d, and we did find out. So what is the distance between these two charges? So from this to the plane is d, and from this plane to the image charge is minus d. So d minus of d is equals to 2d. So the induced electric field will be given by this, that is 1/4 pi epsilon naught q by r square, and here the r is 2d, that is the distance between the two charges. So our correct option is D. Moving to the third question. Here it is given a cube has constant electric potential V on its surface. If there is no charge inside the cube, the potential at the center of the cube will be, and 4 options are provided. Now here we have to look at the first sentence very carefully. A cube has constant electric potential V on its surface. So it is given, it is provided that the nature of potential is constant. So the potential at the center of the cube will also be constant because it is not varying with the distance, right? So the value remains same as it's on the surface. Okay, so our answer will be A. Now let's go to JEST 2013. In this year also total number of questions were 3 from electrostatics, and difficulty of the question level was easy but conceptual. Now our first question is the electric field outside, that is they are considered a spherical shell. Here they are considered a sphere and a spherical shell. So the radius of its, the variable radius is of r. Okay, Now for outside, R greater than capital R, and for inside, capital R must be less than R. Well, capital R must be greater than R. A solid sphere with uniform volume charge density given by this and this respectively, while the electric field outside a spherical shell with a uniform surface charge density is given by this. So these are the equation of electric field for a solid sphere, and this is the equation of electric field for a spherical shell. So we have been given to calculate the ratio of electrostatic energies for the second case to the first case. Okay, so we have to find out the ratio of the electrostatic energy. So at first, what is electrostatic self energy? It is given by this equation, that is U. Here U is electrostatic energy, which is equals to half epsilon naught under integration E in. So what is in? It is inside, the electric field inside plus the electric field outside. Okay, so now for spherical electric field, that is in case of a shell, the field inside is always 0 because there is no medium inside. So U shell is equals to epsilon naught by 2, and here to simplify the calculation I have taken spherical coordinate system, and we know dV, that is elementary volume in spherical coordinate system, is given by r square sine theta dr d theta d phi. So now what are the limits? We have to be very careful with the limits. Here r is from 0 to r, or it varies from, actually it can vary from 0 to infinity, and sine theta, it is 0 to pi, and phi varies from 0 to 2 pi. So what we did is we have to calculate these at outside. So this is outside, so it should be greater than r. So the base value will be capital R, that is the radius of the shell, to up to infinity. That is, we are calculating it at infinity now. So the U shell, that is the electrostatic energy of the shell, is finally calculated at Q square by 8 pi epsilon naught R. Okay, now in case of solid sphere, we perform the same thing, the same formula, but here, as in case of solid sphere, there is a medium inside the sphere also. So E in will also have a value, and we are provided the equation, and we put it here and just integrate thoroughly. Okay, and we calculated 3q square by 20 pi epsilon naught R. Thus we are set to calculate the ratio. So U shell by U sphere is equals to this, and we get the final answer 5 by 6. Now guys, if you have any problems regarding the integration or the multiple integration, do comment below. I will make another video on that too. Now in the next question, we have been provided the equation of two electric fields E1 and E2. Now they have given four statements, that is, both are impossible electric field, both are possible electric field, only E1 vector is a possible electric field, only E2 vector is a possible electric field. So we know that for electrostatic field, del vector cross, that is the curl of E is equals to 0. So at first we calculate the curl of E1, and we find it to be 2y minus 2y I cap minus 3z j cap plus x k cap, which is obviously not equals to 0. Again we calculated the curl of E2 vector. Now here we found that the curl is 0. So we can tell that E1 vector is not an electrostatic field, but E2 vector is a possible electrostatic field. Thus the option will be D, that is E2 is a possible electrostatic field. Now the last question, this is a very conceptual question according to me. A charge Q is placed at the central of a neutral dielectric sphere A and relative permittivity epsilon R. We denote the expression q by 4 pi epsilon naught r square by r. So this r is varying, that is the distance from the center to the point where we are calculating this electric field. Which of the following statement is false? We have been asked to show which of these following statement is false. Now let's start with a solution. So we know that d vector, that is the displacement current, that is the displacement current vector, is equals to epsilon r dot or epsilon r multiplied by the electric field inside dielectric medium, and outside the dielectric medium it is given by this, and epsilon, but that is the permittivity of free space. Now by comparing or by equation 1 and 2 we get that E of dielectric is equals to E of outside by epsilon r. Now what we have been provided, that E of r is the equation of electric field, so r greater than a. If a is the radius of the sphere, so r greater than a by epsilon r. So a is a correct option. Okay, now secondly, so here I have considered this yellow portion as the dielectric medium, and this is the free space or where there is no dielectric medium. Now here also we have to calculate the Q, that asked in the second point, the Q. So here it is equals to epsilon naught, the permittivity is equals to epsilon naught, so the total charge will not change, but inside this the Q will obviously change. Okay, here it doesn't change because it is divided by epsilon naught, but here when we have to measure the electric field, it will be divided by 1 by epsilon along with the r. Okay, by this formula. And in the C option we have been given that if the electric field outside the sphere is here, then the value of charge will be Q. So we got P, B and C both are correct. Okay, now what I have been saying before, that E of r is equals to Q by 4 pi epsilon naught epsilon r square inside this sphere. So obviously the statement D will be false. So thank you guys, this is my video on 2013 and 14 electrostatics. So I will in this series I will discuss all the problems of JEST in different years, chapter wise obviously. So in the next video I will be discussing about JEST 2014 and 15, and it's my request, please give me a feedback on how the videos are or how I will be able to helpful to you guys. And if this video helps you, do like, share and subscribe. Thank you very much.